Welcome back everyone for another SVSU Math and Physics Resource Center video. My name is Brendan. I'm going to be your math tutor, and for this video we're going to get into the root test part 2. Alright, hope you guys enjoy it. So let's kind of recap what the root test is. So we're going to start with a series from n is equal to k to infinity, where k is a constant, of the function of n, a of n. We're going to take, for the root test, we're going to take the limit as n approaches infinity of the nth root of the absolute value of a of n. And if we can get to that to equal to some value L, we can use these three criteria over here to tell us the convergence of the series. So if L is greater than 1, the series is going to diverge. If L is less than 1, the series is going to converge absolutely. And if L is equal to 1, that tells us that the root test is inconclusive and we need to try using a different series testing technique. Okay, so let's go ahead and try working out this example here that I've written down. So first thing I'm going to do is I'm going to identify my a of n. Okay, now let's go ahead and plug everything into our limit. So we're going to take the limit as n approaches infinity of the nth root of the absolute value of a of n. So it's going to be 5e to the n divided by 2 to the 3n plus 1. Okay, so now for my next step I'm going to write this as a fractional exponent. So it's going to be the limit as n approaches infinity of the absolute value of 5e to the n. And also on this step I'm going to break up this denominator using exponent rules. So it's going to be 2 to the 3n multiplied by 2 to the first power, and all raised to the fractional exponent of 1 over n. Okay, so for the next step, what we want to do is we want to distribute this 1 over n to each piece inside of our absolute value. So this is going to be the limit as n approaches infinity of the absolute value. So it's going to be 5 to the 1 over n e to the n times 1 over n is just going to be e to the first power, divided by, so 3n times 1 over n, it's going to be 2 to the third times 2 to the 1 over n. Okay, so when we plug in our limit, let's see what we get. So it looks like we're going to end up getting the absolute value of 5 to the 1 over infinity. So 1 over infinity is just going to be 0, so this is going to be 5 to the 0 power times e divided by 2 to the third times, so 1 over infinity again in the exponent, that's going to be 2 to the 0 power again. Okay, and then these values that have the 0 power, those are both all going to go to 1. So it looks like we're going to maybe end up with e divided by 2 to the third, which is equal to e divided by 8. Okay, so let's go ahead and find out what this value is. So e, the value of e is like 2.71828. So 2.71228 and so on, divided by 8. This is definitely going to be less than 1. Okay, and that's what we needed to know for our criteria up here. So we don't have L is greater than 1, we have L is less than 1, so then that tells us that this series is going to converge. Okay, so if we look back to our original series, what did this function, our convergence, really depend on? It looks like it ended up depending on the e and the 2 to the third, right? Because everything else canceled out when we took the limit to 1. Okay, so you can kind of play with this 2 to the third piece and see if you can get the series to do different things, right? So if you change this 3 here to either make it bigger or lower, what's going to happen to the series? And that's something that you should go through and try it out for yourself. But yeah, so let's just kind of recap what we did. We took our series, we plugged it into our root test, we took the limit, we got the limit to be less than 1, and using the criteria, that tells us that the series converges absolutely. All right, hope you guys enjoyed the video. Thank you for watching.